First off, I'd like to start with a very brief introduction of myself and Extreme Reach for those of you who aren't familiar with us. My name is Brian Vasoff, and for a little over 20 years, I worked as a video editor in the short form and commercial world. A lot changed over that time, and it was pretty fascinating to be part of that evolution. Through the second half of that period, my role drifted slowly towards supporting an infrastructure that was required to run a facility with 7 full-time editors and 18 workstations, all attached to shared storage and working on common projects. This experience drove home the need for clear organization and consistency among multiple users, and where the need for asset management really hit home for me. This post team joined Extreme Reach through acquisition and led to some very natural extensions and merging of workflows. And we skipped forward a few years, and I'm now thrilled and honored to be the product owner for asset management at Extreme Reach and working full-time on this video-first asset management solution. Extreme Reach covers a wide range of services from TV spot distribution, digital ad serving and campaign monitoring, talent payment, rights management, crew payroll solutions, physical storage, and of course, asset management, in addition to many other services. I'd encourage you to check out our virtual booth here at the festival to learn more about us, and we'd love to hear from you. Wherever you're connecting from, thanks for joining me in this session. I've been told that because we only have 20 minutes, we won't be doing any live questions at the end, so I'd encourage you to make some notes of questions or comments that come up and reach out to us afterwards. Let's get started. Video is complex, and it is big, and it's getting bigger all the time with new camera formats shooting ever higher resolutions. The infographic we're looking at here shows the relative size of 1 hour of footage in various different formats. And now there is at least one 12K camera on the market, so this trend towards increasing file size is not stopping. For the rest of this TechLab session, I'm going to talk about one strategy that can be applied to video assets to optimize cost, availability, and security. The strategy is embedded into many Extreme Reach customer implementations and can be used anywhere from a single person operation or a predator, that's a producer editor all in one, all the way up to a large multi-seat environment or studio using one or more DAM technologies. This strategy is designed to exploit the best features of different storage platforms while still maintaining a single point of reference into this ecosystem of assets. Asset management provides the mechanism to access final, fully approved creative, but also reuse raw footage in future projects or for making changes to an existing piece of creative that needs to be quickly repurposed. Asset management platforms that are also tightly integrated with talent and rights tracking information make this an even more valuable resource for brands, agencies, or those predators out there. Having a strategy on what to include in your DAM needs to balance many factors. A lot of them come down to math, but it's not real math. It's more like math from someone who spent 20 years working in an edit suite with lots of approximation built in. It's actually not really math at all. It's more like a series of questions. And if I could somehow turn those questions into equations, I would make an app and I'd retire on the 99 cents per purchase. But for now, let's review them one by one with a particular focus on video assets. First off, how many assets are there in my universe? This is an important question to gauge the scope of the work you're trying to keep track of. This would cover all the assets, including finished versions, production elements, raw footage, and even the physical hard drives that contain material and need to be accounted for somehow. How big are they? Size is a function of resolution, HD, 4K, 8K, times the bit rate, determined by the codec, maybe ProRes versus H.264, times the running time and the length of footage. In the commercial landscape I came from, the running time of finished content was tiny compared to the hours of source footage that was often created for these 30-second or shorter commercials. How often do I need to access the content? Depending on the frequency you need to get at that stored content as a daily task, weekly task, or just occasionally, is an important factor in this formula. What's my tolerance for access time to content? This tolerance has some big implications later. If the business requirements dictate instant access to full resolution content, that limits some of our options for creating more cost-effective storage strategies. But I'll come back to this a bit later with some options. What's my tolerance for losing data? The easy answer is nobody ever wants to lose data. But if that's an actual business requirement, we need to be very deliberate about ensuring we have a secure storage strategy. What's my budget and what's my bandwidth? These two really go hand in hand and will determine what kind of steps we need to take to optimize these storage and bandwidth costs. So with these questions in mind, we can move on and quickly review some of the common storage technologies in use today. Many will be familiar to you, and specifically thinking about them in the context of offline and online categories. Online meaning assets are available on demand with no other delays or interventions required, and offline meaning we have something sitting on a shelf somewhere that needs to be plugged in to get at that data. When money and now bandwidth are no object, cloud-based tools have lots of advantages. There's near infinite scalability, geo-duplication for redundant storage, relative ease of provisioning additional storage, but the cost is high. And the truth is that cost and bandwidth often are considerations and limitations and things we need to factor in. And usually limiting factors like the size of the libraries as they start to grow. It goes without saying that cloud storage in this context relates to online storage. Local storage in the form of NAS or SAN platforms also have the strength of quick access to large files inside a facility, but it's very costly to scale and maintain and often can't be efficiently shared outside the facility. We aren't getting less data, so these platforms need to continually scale up. This type of storage is also part of the online category since the files are still instantly available, even if they are constrained within a facility and not available offsite or to remote users, which has a more serious implication during the work from home or partial work from home model that's so common over these last 18 months. Hard drives are another platform and very often used as an archive tool since they're so easy and relatively inexpensive and very familiar. But standalone drives have a surprisingly high failure rate. The more drives you have in your library, the more likely one of them might not spin up the next time you plug it in. One popular cloud storage provider publishes a quarterly analysis of hard drive reliability. They found after 6 years, a higher than 6% failure rate. So if you can see yourself working on 20 different projects over the course of 6 years, it's not very much. Imagine one of those projects having a problem and suffering data loss. That fits within the average for hard drive reliability. These numbers are a significant improvement from previous published results that showed 80% of hard drives lasting no longer than 4 years without errors. But before you swear never to use a hard drive again, you should know that not all failures are fully catastrophic, and some are recoverable. But any of these types of events have the potential to lead to data loss. Next in line, we have LTO, which stands for Linear Tape Open. LTO is a tape-based data storage platform that provides the benefits of a familiar folder-based system with more robust storage medium that has an estimated shelf life of up to 30 years. The trade-off is LTO libraries aren't real-time. They can browse a file system just like a hard drive, but in order to make use of those files, you need to copy it to a local or network storage. They're also limited to being viewed on a computer equipped with an LTO drive or in a larger scale LTO library system. Hard drives and LTO are both usually considered offline storage platforms, unless, as I'm going to talk about in a few minutes, they are indexed, and those indexes are made available online. This combination of online visibility into offline assets is what we're referring to here as Nearline, a way to bridge the gap of visibility and access versus massive online libraries. With the answers to that first set of questions in mind, in your own particular workflow, and a knowledge of different storage platforms, you might be asking, which platform should I pick? The answer is, you don't. One of the great strengths of DAM is the ability to provide a common surface of visibility across multiple backend storage platforms. There are some options for a platform itself to make certain deductions about when to move live content into lower tier storage, But relying on a DAM or storage platform rule that might be driven by the age of an asset still requires that all of those large source files are loaded into that first tier of storage at the beginning of the process, even if their likelihood of reuse is very low. In this scenario, we can bump into those limitations of bandwidth relating to cloud storage or local storage availability related to NAS or SAN networks. A more intelligent storage strategy should look at different types of content and apply different rules to treat each type or category of content appropriately. Let's look at some concrete examples from a typical production workflow. We would normally expect to see a few different types of finished masters. These are the files that will be sent to broadcasters, web servers, social platforms, and go directly to your audience. These assets need to be 100% perfect, fully quality controlled, and of course, compliant with any talent or rights restrictions. Having these assets in their highest quality means near instant transcoding to fill any needs for platform-specific formats and deliverables. Next up, we have the versioning elements that are normally produced as part of the finishing process. Commonly called generic or superlist versions, they will match the final version, but don't have any on-screen text or graphics in case a piece of text or an offer or a CTA needs to be updated. These are usually paired with a collection of mix and splits or audio stems. And with these audio elements, you could localize to another language, change a voiceover offer, or other piece of narration extremely efficiently. Yet the total size of these elements is typically pretty small when compared to the full set of raw footage and other production elements. For this reason, it makes sense to also keep these types of assets in your highest availability tier of storage right alongside the finished versions. Next up in the ladder of assets that are important for reuse scenarios are production toolkits. These are often, but not always, created and consist of distilled, well-organized elements that might include fonts, layered Photoshop or vector-based files, and possibly project files for After Effects or other effects tools that would make it easy for the same or a different post facility to do some of that versioning or localization work. It should be noted that these types of toolkits are most often created when there's an anticipated need for localization in other global markets or known requirement for other kinds of versioning. They're often zipped into a single file containing all the elements required. When they exist, we need to come back to that question of tolerance for non-instant access to these types of files. If a localization session is likely scheduled a few days in advance, perhaps you don't need these file types in your most expensive storage tier. But this will be a very individual decision based on those initial set of questions and specific workflows. Next might be a much larger and usually less meticulously organized set of projects and graphics files that went into producing the original creative. We also often see lots of in-progress work, and you shouldn't be surprised to see inconsistent naming, lots of V1, V2, final revised, V3, that kind of thing in this collection. We would also expect this to be a much larger collection of files that make it less appropriate to share outside the post facility that created them. There are often many unapproved version edits or working files that might actually be detrimental to the brand if they were shared. A complete archive should definitely find a place for these, but here's where we might not want to call on that high availability storage to house this kind of content. Especially when we have a toolkit available, the likelihood of requiring these files, again, is lower, but not zero. So the priority for these types of assets is secure, long-term storage, likely with some tolerance for non-instant access. And if this sounds like LTO is a good fit, that means you've been paying attention. It would be pretty common for a post house to deliver these elements on a hard drive, but keeping in mind these hard drive failure rates and your tolerance for data loss, an extra step of a clone to LTO would add a layer of security here. And while not specific to a DAM platform, it's an important step to consider. That act of cloning the drive is also a perfect opportunity to pull an index of the drive's full content to give visibility into the assets that will not be uploaded into the DAM platform. Next up is another interesting category that spawns a lot of questions and opportunities for more efficient workflows: raw camera footage. All of those questions from that first list come into play when thinking about how to handle the archive of raw camera footage. How much do we have? What resolution? This is where our archive can easily go from 20 or 30 gigabytes into 3 to 10 terabytes very quickly. This range is not uncommon for commercial productions, creating a handful of 30, 15, and 6-second creatives. The size of these files is the first barrier to adding these to high availability storage. But in many scenarios, they can provide a rich library of footage, your very own stock footage library, that could be reused in future projects, potentially saving time and production budgets from reshooting that product shot or ingredient falling in slow motion. I mentioned earlier that tracking rights and talent contracts as part of this workflow can make that stock footage scenario very efficient. We have a couple of options with raw footage. One would be to have the editorial team collect shots that appear to have a reuse value and keep them aside. And while that's an ideal place for that type of decision, editorial teams can often be quite rushed or be billing at a very high rate and make it impractical to use their time to curate footage for possible reuse. Another option, if the likelihood of reuse is a little lower, or if the quantity of footage is extremely large, is to index that source content. Assuming this post facility has archived the final project to a hard drive, or maybe even an LTO already, that content can be indexed, either as a simple image of the folder structure with all the file names, or as a richer document that contains film strip images of the video files found on the hard drive. These index files typically can be saved as a PDF and will be loaded into a DAM platform, into the DAM for access and review, bridging that gap between offline and nearline. Another option with raw footage is to create a proxy collection. Transcodes of those massive camera files are often created as dailies for rough cutting and post-production, but creating a second set of proxy files with a smaller file size can still give Blu-ray quality playable files suitable for reuse that become much more manageable to have in high availability storage. Matching file names and file paths to the camera's source material means that it would be very straightforward to conform back to the original camera files if that was required. They can be restored from the deep storage formats, while the new edit is being assembled from proxy files. We can further break down camera footage content into raw footage and color-corrected selects. A common solution to balance your storage footprint with access to the stock footage type of library is to leave the raw footage as indexed PDF material, but create proxies of the color-corrected footage in the most appropriate format for your needs. And those proxies can then be tagged with both project and shot-specific metadata. So we covered a lot of ground here so far and have been talking fast. So let's take a moment to review all of this workflow. Taking everything we talked about into account, the DAM ingest workflow might look something like this. A hard drive arrives ready for processing, and we would start off by cloning the entire drive to LTO, and this would meet our disaster recovery and fiduciary responsibilities. During the clone, we can index that content to a PDF, either as a directory only or as a film strip with thumbnails. The finished files, generics, mix and splits, and toolkits can be uploaded to the DAM in their full resolution. And color-corrected shots can be treated either as the index or as proxy files uploaded into the platform for review and tagging. This kind of process can play a key role in an optimized DAM strategy that can scale up from the smallest asset management needs all the way up to large enterprise solutions where the visibility across multiple post houses and creative agencies can be a challenge and a barrier to reusing potentially valuable content. I'll say thank you very much now for your time and attending this session, and I hope this has piqued your curiosity and raised some questions, and we'd love the opportunity to discuss them with you.